Number 9. The key thing with number 9 is, and I don't know, Quinn, whether from question to question whether this is going to, I would think it's going to be a consistent idea, but I don't know what all the different types of problems are going to give you here. But when we use, hopefully we realize at the center, that's the H comma K, right? So that's the, let's see here. Alright, so we got negative 4, comma 4. So that's where we're seeing x minus negative 4 and y minus 4. But now to find the distance, to find the radius, I saw this in the last class. People were like going over to like that point right there and saying that is located at like 0.5 comma 4. Okay? Don't do it that way because we're not 100% sure that that's 0.5 comma 4 because it might be 0.48 comma 4. It might be 0.475 comma 4. Does that make sense? It's not. We're not really good at kind of guesstimating what that's at. Now, if you got 20.25, the answer for you was probably something really close to that. Okay, if you go back and reevaluate this, kind of using maybe a different point, you should get something really close to that. But if we circle the, or go around the circle here, and what I want to do is I want to find some points that intersect at grid lines. Now my calibration is kind of off there on my computer, but I want to find a point that I know intersects exactly at the apex of those two grid lines crossing, okay? Because that tells me 100% that I've got whole number or integer ordered pairs instead of having to guess maybe what that rational number is there, okay? So I'm seeing that it looks like that point there is crossing at two grid lines, and there should be a series of others. There's one, there's one, there's one, there's one, there's one, there's one, and there's one. So those are all maybe convenient points. The last class we did a question of this, and I think there's only like 4 or 5 points. This looks like we've got at least 8 that we could choose from. Now it doesn't matter which ones you choose. I just think that if you're going to do this, be thoughtful of the process and know what you're going to do next. We're going to use a distance formula, right? So distance formula has, if we write it out, we're doing some subtraction between x's and y's, right? What is the easiest number to subtract from something? 0, okay? So if I can, I'm going to try to use maybe a coordinate that has, or a point that has coordinates of 0. So maybe I use this one where it's 0, comma 6. So now when I subtract my x's, negative 4 minus 0 is easy. That gives me 16 when I square it. And now I'm going to subtract my y's, so I get 6 minus 4 is 2. Square that gives me 4 again. So there I get right at the 20. Okay? Now remember, that's the distance of that segment right there, right? So that's your radius, correct? What is this form or value in our equation? What form is that in? Radius squared. So if this is r, then r squared is just 20. Okay? So does that make sense then? To choose those points that are maybe a little bit easier to guesstimate, or I guess eliminates guesstimating. If we look at this, so for instance, let's say you chose, let's say negative 4, comma, that point looks like it would be 9, 8.5. Okay, if you did this, you would probably get, with those two, you would probably get 20.25. Very, very close, okay, to the actual 20. But what that tells me, because they're not the same, that this point here really wasn't negative 4, comma 8.5. Does that make sense to everybody? Okay. And we could quickly maybe do that on GeoGebra and actually ask it what that point is, and we'll see that it's not 8.5. Last class had the same question, so that's a good way to talk about that. Anything else? Any other?
Would you have a donut?
No. I'm fat, and I'm trying to not be so fat. But thank you, I appreciate it.
Ethan, I'll take a donut. I'll take one.
If I would have taken a donut, anybody would have bought it off of me?
I would consider.
16.
I don't know. I guess I wasn't even stuff there.
Good. All right, so when you see questions like this and it says test for symmetry, if you remember yesterday at the end of class we talked about this. When you're testing for symmetry, you're going to have three options, and you might have symmetry across different axes. I mean, you might have symmetry across the x-axis only, but you might have symmetry across the x-axis and the y-axis. Okay. If I have a circle centered at 0, 0, I've got axis around all three things we talked about: the x-axis, the y-axis, and the origin. Does that make sense? You think about folding that circle, and you see it's going to fall on itself a lot. So when you're doing this, just because you find yes for one of these, doesn't mean the other two are no. Does that make sense? You've got to test them all. And we talked about, let's see, can I zoom in on this? If anytime you guys can't see the equation or the expression, let me know. I don't like that either. Let's do it this way. So we're taking x to the 6th, y to the 6th, plus x to the 4th, y to the 4th equals 9. Now, that's an ugly equation, right? Okay. And you're going to take, maybe you would try to solve that for y. You're going to find out that maybe that isn't even solvable for y. You can't isolate y to the first power all by itself. There are equations that exist like that. Okay. And the reason they give this to you is they know that at your level, you are using a TI-83 or 84, right? And if you're able to type in an equation, say I gave you y equals like x squared plus 5, and you weren't sure about the symmetry, but you can type that into your calculator and say, oh, I can fold that on the y-axis, it's got y-axis symmetry. You can get the answer real quick, right? Without having any algebra understanding. Giving you questions like this, testing the same thing, but those types of equations eliminate your ability to use the calculator, okay? Unless you have an implicit graph, for instance, GeoGebra, just while we're waiting for that other thing to load. If I were to go to GeoGebra, I can go, and this is another reason I'm not going to let you use this on a test, but I can go x to the 6th times y to the 6th plus x to the 4th, or y to the 4th, equals, I think it was 9. And we can graph that, and it does a really, really good job of graphing that, right? Okay. And then hopefully you can recognize that that's probably got x-axis symmetry, it's probably got y-axis symmetry, and it kind of looks like it has symmetry about the origin, right? Okay. So you could get that question if you had an implicit grapher, you could go ahead and do that real quick, not know any algebra, and get the right answer. They're trying to inhibit you from doing that. And here you're seeing they label it as an implicit curve. So what that tells me is that GeoGebra is recognizing you can't solve this for y. If you remember yesterday, we clicked on that and we were able to change the format. Okay, it was either an expanded form or a form that solved for y. Here it doesn't have that ability, so it's telling me that it's not solvable for y. So here's the algebra that you would have needed to go through to figure this out. If I've got x-axis symmetry. Let's just write the rule down here for x-axis symmetry real quick. Says if I have the point x comma y on my graph, if x-axis symmetry exists, what's the other point that we have on our graph? Good. X comma negative y. And I've been writing this arrow going one way, but it's actually a two-way street. If x comma y exists, then x comma negative y exists, and vice versa. So now we're going to test that, see if that exists. Everywhere I see an x, so basically the equation right now is set up in regards to that ordered pair, x comma y. We want to see, do we get the exact same equation when we use that point? So we have to substitute things with that point. So again, x is going to substitute as x, so we still get x to the sixth. Okay, but now y is going to substitute as negative y, right? So we get negative y to the sixth. Plus then, x again becomes x, so x to the fourth. And then y is now negative y, and that equals 9. My suggestion to you throughout every course that you take from this point to your last math class that you ever take, when you substitute something, whatever you're replacing it with needs to be in its own set of parentheses. Does that make sense? So that you make sure that exponents and maybe distributive property and that kind of stuff gets taken care of in an appropriate manner. If I would leave those parentheses out, what I would be writing is that the y is getting raised to the sixth power, but the negative is not. Does that make sense? Well, we want to make a full substitution. Okay. So when we do this, we have to now simplify. So x to the sixth is simply just x to the sixth. But what's negative y times 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 negative y? Y to the sixth, right? If you have even number of negatives, it's going to evaluate to be a positive number, right? Negative times negative is positive, however many times you do that. So negative times negative, negative times negative, okay? You've got 4 of them, positive. 6 of them, positive. 8 of them, positive. So x to the fourth then stays x to the fourth. That's what's negative y to the fourth going to be? Y to the fourth, and that should equal 9, right? Once we simplify, once we substitute and simplify, if what you're left with is exactly with what you started with, what that tells you is that you have symmetry about the x-axis. Okay. So yes, we have x-axis symmetry. Okay. So now we're going to do the exact same thing, but we're going to do it with y-axis. So y-axis symmetry, we're looking at the point x comma y. If that exists, then negative x comma y exists. So it's the same procedure now. Plug things in with this point. So x is going to be negative now, right? And the y is going to stay y. So we're going to go negative x to the sixth, y to the sixth, plus negative x to the fourth, y to the fourth, is equal to 9. Well, for the same reason as before, that's going to become positive x to the sixth, y to the sixth, plus positive x to the fourth, y to the fourth, is equal to 9. Is that exactly what you started with? So now we have y-axis symmetry. Okay. Now we could cheat and realize that picture-wise, if you have folded something along the x-axis and it had symmetry, but then you also fold across the y-axis and it has symmetry at the same time, you're going to have origin symmetry. Okay. But what I think is useful is maybe to actually go through the process and say, if I have x comma y, so this is for the origin, that's going to be negative x, negative y, right? Okay. And we talked about that. That is also, if you remember back to geometry, that's a 180-degree rotation. They're synonymous for one another. So now everywhere I see